Hello and greetings to everyone. We are going to treat the remainder and the factor theorem. We take the first one, the remainder theorem. You will discover that when we treated division of polynomials, we saw that when we divide two polynomials, we obtain a remainder and the quotient. Let's take this example. It goes divide f of x equal to x cubed plus 4x squared minus 2 by g of x equal to x minus 2. Take solution. We have to divide f of x by g of x. This will simply be equal to x cubed plus 4x squared minus 2 all over x minus 2. For us to divide these two polynomials, we are going to make use of the method of long division. We are going to send out x minus 2. Then we send in x cubed plus 4x squared. The term in x is absent plus 0x minus 2. X cubed divided by x gives us x squared. X squared times x gives x cubed. X squared times negative 2 gives negative 2x squared. Then we subtract. X cubed minus x cubed gives 0. 4x squared minus negative 2x squared gives us 6x squared. Then we bring down plus 0x. 6x squared divided by x gives us plus 6x. 6x times 6x times x gives us 6x squared. 6x times negative 2 gives us negative 12x. Then we subtract. 6x squared minus 6x squared gives 0. 0x minus negative 12x gives us positive 12x. Next step, we are going to bring down negative 2. 12x divided by x gives us plus 12. 12 times x gives us 12x. 12 times negative 2 gives us negative 24. Next step, we subtract. 12x minus 12x gives us 0. Negative 2 minus negative 24 is the same as negative 2 plus 24, which is equal to positive 22. We can express f of x divided by g of x as, write down the quotient, which is what we have up here, x squared plus 6x plus 12 plus the remainder, which is 22 all over x minus 2. We know this is the same as f of x all over, we know g of x is x minus 2 is the same as x squared plus 6x plus 12 plus 22 over x minus 2. The next step, we are going to multiply all through by x minus 2. Multiplying all through by x minus 2, this will give us x minus 2 all over 1 times f of x over x minus 2 it will be the same as x minus 2 times x squared plus 6x plus 12 plus x minus 2 all over 1 times 22 over x minus 2. At the left hand side, x minus 2 at the numerator will strike off x minus 2 at the denominator. At the right hand side, this x minus 2 will strike off this one. We will simply be left with f of x to be equal to x minus 2 times x squared plus 6x plus 12 plus 22. This is what we are going to obtain. At this stage, we are going to let the quotient, we're going to let h of x to be equal to x squared plus 6x plus, this is 12, plus 12. This will simply give us f of x to be equal to x minus 2 times h of x plus 22. At this stage, if we put x equal to 2, x equal to 2, we can call this one equation 1, x equal to 2 into 1. The reason why we are putting x equal to 2 is simply because 2 minus 2 gives us 0, and 0 times h of 2 gives us 0, so this term will disappear. That is, replace x with 2, f of 2 will be equal to 2 minus 2 times h of 2 plus 22. This will give us f of 2 to be equal to 0 times h of 2 plus 22. This will give us f of 2 to be equal to 22. Since 0 times h of 2 disappears, 22 is the same as the remainder. So we know f of 2 is equal to 22, which is equal to the remainder. When we divide the polynomial f of x by g of x. Now we can state the remainder theorem. The remainder theorem states that if a polynomial f of x is divided by, let's say, x minus e, where e is a constant, then f of x will simply be the same as x minus e times g of x plus the remainder, where g of x is simply the quotient after dividing f of x by x minus e, and the remainder is simply equal to f of e. So it simply means for us to get the remainder, if we are to divide the polynomial f of x by x minus e, the first step we are going to equate x minus a, which is a divisor, to 0. Then we make x the subject of formula. X will simply be equal to a. To get the remainder, we are simply going to replace x in the polynomial f of x by a. So this is how we get the remainder. Note this down. If f of x is of order n, that means the polynomial which is to be divided by x minus a, if it is of order n, then the quotient g of x is of order n minus 1. The order of the quotient is always less than the order of the polynomial. Now let's look at an example. It goes, find the remainder when f of x is equal to 2x cubed minus 5x squared plus 3x minus 7 is divided by x plus 3. We are going to make use of the remainder theorem. We know f of x is equal to 2x cubed minus 5x squared plus 3x minus 7. It is to be divided by x plus 3. Since we are going to make use of the remainder theorem, we are going to equate x plus 3 to 0, and then make x the subject of formula. X will simply be equal to negative 3. Now, using the remainder theorem, the remainder would simply be equal to f of, replace x with negative 3. It simply means in the polynomial f of x, anywhere we see x, we have to replace x with negative 3. So this will be equal to 2 times negative 3 cubed minus 5 times negative 3 squared plus 3 times negative 3 minus 7. This will simply be equal to 2 times, negative 3 cubed. Negative 3 times negative 3 times negative 3 gives us negative 27 minus 5 times negative 3 squared gives us 9. Positive 3 times negative 3 gives us negative 9 minus 7. This will simply be equal to 2 times negative 27 gives us negative 54. Negative 5 times 9 gives us negative 45 minus, negative 9 minus 7 gives us negative 16. The next, negative 54 minus 45 minus 16 will simply be equal to negative 115. This will equal to negative 115. And this negative 115 is a remainder when we divide the polynomial f of x by x plus 3. We move now to 2 which is the factor theorem. We know a number n is a factor of another number m if we divide m by n, it gives us a whole number c. Then in such a case, we are going to say n is a factor of m. That means leaves no remainder. In this case, the remainder will simply be 0. So if we divide two polynomials, if we divide polynomial f of x by another polynomial g of x, and it leaves no remainder, in such a case, we are going to say the polynomial g of x is a factor of the polynomial f of x. Let's write this down. If the polynomial f of x is divided by x minus e, and the remainder is 0, then x minus e is a factor of f of x. That means in this case, after performing the division, we obtain only the quotient, since the remainder will be equal to 0. That is, we equate x minus e to 0, then x will be equal to e. It simply means our remainder, the remainder is equal to f of e, which is equal to 0. That means f of e is always equal to 0 if x minus e is a factor of f of x. In this case, we are going to conclude that the polynomial f of x will simply be equal to x minus e times g of x, where g of x is the quotient you obtain after dividing the polynomial f of x by x minus e, since the remainder will be 0. If we take this down by using the factor theorem, we can be able to factorize polynomials as a product of their linear factors. Talk of linear factors, that means factors with degree 1. Take an example. First one, it says find the remainder when x cubed minus 2x squared minus x plus 2 is divided by x plus 1. X solution. First step, we are going to start by equating x plus 1 to 0. Then we make x the subject formula. X will be equal to negative 1. We can let f of x to be equal to polynomial x cubed minus 2x squared minus x plus 2. We know the remainder is simply equal to f of, we are going to replace x with negative 1. So this will equal to negative 1 cubed minus 2 times negative 1 squared minus negative 1 plus 2. So this will be equal to, negative 1 cubed gives us negative 1 minus 2 times negative 1 squared gives us 1. Negative 1 times negative 1 gives us positive 1 plus 2. So this will be equal to negative 1 minus 2. 1 plus 2 gives us 3 plus 3. This will simply be equal to negative 1 minus 2 gives us negative 3 plus 3, which is equal to 0. So it simply proves that x plus 1 is a factor of x cubed minus 2x squared minus x plus 2. We go to the next example 2. It says factorize the polynomial f of x equal to x cubed minus 5x squared plus 2x plus 8, and hence solve the equation x cubed minus 5x squared plus 2x plus 8 equal to 0. When we are asked to factorize a polynomial, that means we are to give that polynomial, we have to express that polynomial as a product of its linear factors. We take solution. We have f of x is equal to x cubed minus 5x squared plus 2x plus 8. First thing, we are going to start by looking for a value of e, that means a constant, such that when we replace x with that constant, the right hand side of this our polynomial will be equal to 0. Now if x is equal to e, then x minus e is equal to 0. It simply means x minus e is a factor of the polynomial f of x. We are going to make use of the method of try and error to get the value of e. And for us to easily get the value of e, what we are going to do is we are going to start by writing out the factors of the constant term, which is 8. We write out all the negative and positive factors. We have negative 8, negative 4, negative 2, negative 1, 1, 2, 4, 8. We are going to insert these factors here. When we insert the factors, one of these factors will verify the set condition. That means f of that factor will be equal to 0. We are going to try those factors. If we try, for example, -1, f of -1 will simply be equal to -1 cubed minus 5 times -1 squared plus 2 times -1 plus 8. And this will be equal to -1 cubed gives -1 minus 5 times -1 squared gives 1. 2 times -1 gives -2 plus 8. This will give us -1, -5 times 1 minus 5, -2 plus 8 gives us plus 6. This will be equal to -1 minus 5 gives us -6 plus 6 gives 0. You know, x equal to -1 will give us our polynomial f of -1 to be 0. Then, if we transfer -1 to the left hand side, x plus 1 is equal to 0. Then, x plus 1 is a factor of polynomial f of x equal to x cubed minus 5x squared plus 2x plus 8. Now, after getting one of the linear factors of the polynomial f of x, the next step is we are going to make use of the method of long division to get the quotient. We know if you make use of the method of long division, since x plus 1 is a factor of this polynomial f of x, then the remainder will simply be 0. So let's carry out our long division, dividing x cubed minus 5x squared plus 2x plus 8 by x plus 1. Let's perform the division. X plus 1 goes out, bringing x cubed minus 5x squared plus 2x plus 8. X cubed divided by x gives us x squared. X squared times x gives x cubed. X squared times 1 gives us plus x squared. Then we subtract. X cubed minus x cubed gives 0. Negative 5x squared minus x squared gives us negative 6x squared. If we bring down plus 2x. Negative 6x squared divided by x gives us negative 6x. Negative 6x times x gives us negative 6x squared. Negative 6x times 1 gives us negative 6x. Then we subtract. Negative 6x squared minus negative 6x squared gives us 0. 2x minus negative 6x gives us 8x. Then we bring down plus 8. 8x divided by x gives us plus 8. 8 times x gives us 8x. 8 times 1 gives us plus 8. Then we subtract. 8x minus 8x gives 0. 8 minus 8 gives 0. You can see the remainder is equal to 0, which is a proof that x plus 1 is a factor of x cubed minus 5x squared plus 2x plus 8. It therefore means our polynomial f of x is the same as x plus 1, which is the divisor, a factor, times the quotient, which is x squared minus 6x plus 8. Remember, factorizing a polynomial simply means we have to express the polynomial as a product of its linear factors. X squared minus 6x plus 8 is not a linear factor, it is a quadratic factor. So the next step, we need to factorizing x squared minus 6x plus 8. In this case, we have the factors of 8. We have negative 8, negative 4, negative 2, negative 1, 1, 2, 4, 8. We need two factors of 8 such that their sum is equal to negative 6, the coefficient of b, and their product is equal to 8. You'll see if we take negative 4 plus negative 2, it gives us negative 6. Negative 4 times negative 2 gives us positive 8. X squared minus 6x plus 8 is simply the same as x squared plus, we are going to replace negative 6 with negative 4. We know positive negative, negative will stay, negative 4 minus 2 times x plus 8. This will be equal to x squared. We are going to expand this bracket plus negative 4x minus 2x plus 8. This will equal to x squared. We know positive negative, negative will stay, minus 4x minus 2x plus 8. The first pair, x is common. X times x gives us x squared. X times negative 4 gives us negative 4x. The second pair, negative 2 is common. We know negative 2 times x gives us negative 2x. Negative 2 times negative 4 gives us 8. We have two terms. And the two terms we have, x minus 4 is common, times x minus 2. Therefore means the factorization of x squared minus 6x plus 8 is equal to x minus 4 times x minus 2. So we are going to replace it here. So this will give us our f of x to be equal to x plus 1 times x minus 4 times x minus 2. We are going to conclude therefore the polynomial x cubed minus 5x squared plus 2x plus 8 is the same as x plus 1 times x minus 4 times x minus 2. You can see it is a product of linear factors. The next part of the question is asking us to solve x cubed minus 5x squared plus 2x plus 8 equal to 0. For us to solve this equation, we are simply going to replace polynomial x cubed minus 5x squared plus 2x plus 8 by its factorization, which is x plus 1 times x minus 4 times x minus 2. So this will be equal to 0. This polynomial is of degree 3. It therefore means we are going to obtain 3 solutions. At this level, we are going to say either, since this is a product, either x plus 1, first linear factor, will be equal to 0, or the second linear factor x minus 4 is equal to 0, or the third linear factor x minus 2 is equal to 0. So this will give us 1, 2, 3 linear equations. And the 3 linear equations we are going to solve for x. The first one, x will equal to negative 1, or the next, x will equal to 4, or x will equal to 2. Therefore, we're going to conclude, therefore, x equal to negative 1, or 2, or 4 is the solution of x cubed minus 5x squared plus 2x plus 8 equal to 0. The reason why we are making use of or is simply because x cannot take two values at the same time. Now we are going to end by taking down exercise for application on this. Exercises for application. Question 1 goes, find the remainder when x cubed plus 2x squared plus 5x minus 4 is divided by x minus 2. Question 2. Given that x minus 2 is a factor of f of x equal to x cubed plus x squared minus 4x minus 4. Now, factorize f of x completely. Go to question 3. It says find the values of a and b if x plus 1 and x plus 2 are both factors of f of x equal to x cubed plus ax squared plus 8x plus b. Go to question 4. Given that x plus 1 and x minus 2 are both factors of f of x, which is equal to 3x cubed minus 5x squared plus ax plus b. Question E says find the values of A and B. Question B says factorize f of x completely. It's after finding the values of A and B, we are going to factorize f of x completely. Question C says solve the equation f of x is equal to 0. We go to the next question, question 5. It was given that f of x equal to a x cubed plus 2x squared minus 3x plus b gives a remainder of -1 when divided by x plus 1 and a remainder of 3 when divided by x minus 2 full stop equals find the values of A and B. We are going to end here. In our next video, we are going to correct the following exercise for application. If in case you have any worries, make sure you leave your questions at the comment section. Please like the video, share, and subscribe to this YouTube channel. Thank you very much for watching.